Hello and welcome to another video on my channel. In this video I'm going to continue discussing the expression evaluation topic in Java, and if you recall, the library that I'm using for expression evaluation is exp4j. And to briefly recap about what I talked about in the last video, I mentioned that the way this works is you define an expression as a string, and then you define which parts of this string are actually your variables, right? So variables are defined by the user. There are some built-in functions and operators. So we said that the operators and functions are built in, okay? Like sine, cosine, operators are times raising to some power and division and etc. Okay, and we said that the way this library works is it based on the input that the user provides, it breaks down the expression into some tokens and passes it to a shunting yard algorithm, which determines how to evaluate the expression. Basically, it finds the order of evaluation and determines the operator precedence. Okay, that's why we have a tokenizer package. So there are four main packages here: function, operator, shunting yard, and tokenizer. And the two main classes are expression builder, that is where the user specifies the name of variables and then builds the expression to create the tokens, and then the expression actually runs the shunting yard algorithm. But then now the question is that I mentioned that the operators and functions are predefined. So the question is, what if I want to also implement my own function? For example, I define a function and call it myfunc, and it's a function of x, for example. And now let's say I have a string expression as x plus myfunc of x, and I want to just be able to evaluate this based on the implementation that I have for myfunc function. Okay, so how do I do that? Now the way you do it is by extending this function class. Now we'll look into this function class, but this function class is not final. It has some final fields, but it's not final, which means you can actually extend it and implement your own version of the function. So here's an example which I call it the custom function, and this custom function basically extends the function, which means it's a subclass or subtype of function. Okay, and when you do that, you have to override the constructor, because there is a field called name, which is the name of the function. In this example, it's going to be myfunc, and it has to pass it to the super constructor or super object, which is the function. Function is the super class, custom function is the subclass. Okay, and also it needs to override one particular method, which you probably can guess which method it is. It's the method that you have to define the mathematics of this custom function. Here, let's say I'm defining this as the argument to the power of 2. Now the beauty of this type of implementation, which is called a vararg implementation, vararg, variable argument. Now the beauty of this is that you can have you can either have one input or multiple inputs. Okay, so your function can be a function of single variable or multiple variables, and this array of args are basically is the array of your arguments. Here I'm assuming it's just a function of one variable, so therefore I'm assuming that this variable, this args, has one component, one element, which is arg0 at index 0. And this custom function is basically taking this argument and raising it to the power of 2. It's a very simple thing. Okay, and then when you go through the routine of building your expression and evaluating that, what you need to do, you need to define an object of type custom function and give it the name. So you set the name in the constructor, and this name will be final, which means After you define it in the constructor and the final field, which is the name, is initialized, you cannot change it again. Okay, there is no set method for changing the name because it's a final field. It can only be it can only be assigned during the initialization, and that happens through this direct call to the super constructor. Okay, and so I define this. So the name of the function is given in the constructor, and the mathematics of the function is already defined in the class when we implemented this object. Okay, now let's say I start with the string s, which is x plus my func of x. Okay, previously we only had predefined functions like sine, cosine, whatever, and now I have my own defined function, my func. Okay, and now the routine is that we start with the expression builder, pass our expression to this, and then set the name of the variables, tell Java which parameters, which parts of this expression actually are variables, which is x. But then we also call another method, which is functions or function. I mean, if you have multiple functions, you can call the functions method, and it takes a vararg input, which means it can have multiple inputs. You can have multiple custom defined functions. Here I only have one. Okay, so not only I tell the Java which parts of the expression are my variables, I'm also telling it my custom defined functions. Okay, and now the expression builder knows everything else. It knows the operators, or it assumes that all the operators are the ones that are predefined. Okay, and now this my underscore func is also something defined for the expression builder. When it runs or calls the tokenizer, it creates a token for this expression my func, and it knows that it's a type of function. Okay, and then it looks into this apply method to see how to evaluate that. So tokenizer has no problem here. And then the expression, and again we can set the value of this variable x, and everything will work. So let's head to Eclipse and test this. Now let's first look at the expression builder and the function. As I mentioned, so in the function, first of all, function class is an abstract class. Okay, and which means it can have actually abstract methods or abstract fields, and the reason it's been defined as an abstract method is because it has this abstract method called apply. So in order to force the user to implement the apply method every time they extend this class, they had to define it as abstract. Okay, now as I mentioned, the name is a final field, which means, and it's protected, which means the only access that you have to it is through the subclasses. It's private with the exception of subclasses. It's the meaning of the protected. Okay, and in Eclipse there is this yellow diamond, which is has a little bit of hole inside of it, which means it's a field. Yellow diamond means it's private and it has the label of final. Okay, so we have two final fields and are protected number of arguments, because you can have more than one argument for this function. The function can depend on multiple arguments, and that's the beauty of implementing the apply method as an vararg input. Okay, so two protected final fields, two types of public constructors. Okay, circles are methods, and green is public, and it has the label of constructor, and two public methods, get name, get number of arguments. Note that there is no set name or set number of arguments, because these are finals, these are constants. Once you initialize them, you cannot change them. And there's an abstract apply method which is public, and there's a deprecated method called, and it's static, called get allowed function characters. And the newer version of this function is the new one, this public static method, which is valid function name. So when you extend this class, you only care about this apply method, and it automatically forces you to have a call in your constructor to the superclass, which is basically this one. So you can either implement this or this one and specify the number of arguments. Okay, now this is our abstract class, and then here I already defined a custom function, and in the custom function I extend the function, and my custom function is not abstract, it's just a public regular class. And when you do this, it forces you to basically have a call to the super constructor and pass in the name. So the constructor has to at least have one parameter, which is the name, and it passes it to superclass. And basically what happens is that it assigns this, it initializes these two final fields, okay? And then it also asks you to implement this abstract method apply with a vararg input. And right now my power of 2, raising to power of 2, is has only one argument. Okay, now in the function class demo, I create some function func1 of type custom function. Okay, I didn't need to have it as custom function, it could also be function. I believe it should work. Let's import it from the object hunter, and that's because this is polymorphism. So let me just write it down. Polymorphism. If you are not familiar with what polymorphism it is, it's basically states that every subclass can be assigned to a superclass. Okay, so every subclass is a type of its superclass, so you can have this kind of polymorphism. Okay, and then I define my string with variable x and an unknown expression, which is my func, and then it's not a built-in function, right? It's not the name of a built-in function. And then I define my expression builder, set the names of the variables. So tell Java, okay, x, this x, wherever you see this x, is my variable. Okay, but then I use this one too. So this is the new addition to the previous cases. So we also set the functions. Now if you look at we also, if we only have one function, I can just call the function. If you have a list of the functions, you can just call this method. Or if you have multiple functions and they're not in a format of a list, you just use the varargs method of type function. Okay, here I'm just calling functions, and I have one function, which is fine. Okay, and then we create the expression by calling the build method on the expression builder, and again it calls the tokenizer and goes through the expression and understands what is what. And now the tokenizer understands that, okay, my func is a predefined function, and it already knows how to implement it. And then you set the value of the variable x, and then you call the evaluate method, and this should work. Yes, 6. So if you recall, my func was taking x and raising to the power of 2. So basically this is equivalent to x plus x squared. 2 to the power of 2, 4 plus 2 is equal to 6. Now if I comment this out, the tokenizer probably complains that it doesn't understand what my func is. It's a token unknown to the tokenizer. Unknown function or variable my func. Okay? So the tokenizer doesn't understand what it is. You have to tell it what it is. And we're telling it, okay, it's a function. Okay? So this is how you define your own function. Now, exactly in the same way, another thing that you can do is, or another question that you can ask is, okay, what if I want to define my own operators? Maybe there is some symbols that I use for some sort of operator that is not predefined or not built in. So exactly in the same way, we have an operator class in the operator package, and you just basically extend it and create something called custom operator. And you have to define the symbol of this operator as a string and number of operands that this operator operates on. For example, if it's sorry about the background noise. For example, if it's something like raising to some power, it operates on basically two operands. One is the base, the other one is the power. Okay. Is it left associative or not, and what is the precedence? And it directly calls the superclass, and then again it also has the apply. Now here, unlike function, the apply basically you have to tell it how to operate, how the operator is defined between the two operands. So if my number of operands is 2, basically args has two elements, arg0 and arg1, and you have to tell it how these are related to each other, how they interact with each other. For example, in Python, a star means power, the power operator. So if I say a star 2, it means a to the power of 2. Okay, so the symbol for my operator would be a star, and it operates on two operands. And the mathematical expression is take the first argument, arg0, and raise it to the power of args1. Okay, and this is example. Let's say op1, it's a custom operator, the symbol is star, two operands, and it's not left associative, right? And then the precedence, I just use one of the built-in precedences in the operator class, which is the power precedence. Okay, and then let's define the string as x star 5, and the routine expression builder, pass the expressions, tell it what symbols are the variables, and the new one is this one. Now I call the operator function or operator method in the expression builder, and tell it, okay, this symbol star is some sort of operator with these properties. Okay, then tokenizer understands that, okay, this is an operator, puts it in the operator stack. And then expression, you create an expression by building the expression builder and set the variable and evaluate. Okay, so let's head to Eclipse and look at it. I've already defined a custom operator which extends the operator, and it forces you to have a call to the super constructor, and also it forces you to override this apply method. So if we go here, if you go to the operator class, and it's an abstract because the override method is an abstract. So abstract classes can have non-abstract methods or constructors, that's totally fine, but they can also support abstract methods. And the feature of being abstract, the property is that it forces the subclasses to implement this. Now, another way that some people normally use is that to make it a regular function, but then inside a regular method, but then inside of it you just throw an exception saying that you have to implement the method. But that's not good because it just interrupts the program. It's better to just go with abstract and force the programmer to implement it. So my goal is to take the argument 0 and raise it to the power of argument 1. Okay? Now let's go to the custom operator demo. I can also define it as an operator. It already understands this, and the import is already there because of polymorphism. Any custom operator is basically an operator. So the symbol is star. It takes two operands. It's not left associative, and the precedence is just the precedence of power. So if we go and look at this should have the highest precedence. The power has the highest precedence, okay? And this is my expression, x star star 5, pass it to the expression builder. My variable is x. Now this is the new line that has been added. New line to define the operator, the new operator. Okay? Now I'll tell the expression builder, when you call the tokenizer, tell it that star star, this op1 star star is basically an operator, and it has to go into the definition of the apply method in this class to see how to calculate the value of this operator. Okay, set the variable to 2 and then evaluate the result. So this should give me 32. Yes. Now let's say, because of the precedence, if I put this 3 to the power of 5, 243, which is correct. 3 to the power of 2, 9. Okay, I hope this video was useful, and thank you for watching. Please comment, share and subscribe, and I'll see you in the next video.